So, hello everyone, and good evening, everybody. Am I audible to everyone? Okay. Today, it's a very informative lecture is going to be happen, and the introduction to artificial neural network and the error analysis. And we have today our eminent guest, Dr. Abhijit Majumdar. Okay, Dr. Abhijit Majumdar is a right now is a associate researcher from the University of Notre Dame, USA. And his research field is now he's an expert researcher in the statistical modeling and the modeling with the mathematical biology. So he's now going to discuss about the artificial neural network and what is the significance and the view of the data analysis and the machine learning and how different types of errors are there which should be analyzed to perform a very good picturize the data. Okay, so Dr. Abhijit, can you hear me?
Yes, I can hear you.
Okay. So I request everyone to please turn on your camera. I request all the trainees and all the interns, please turn on your camera. Okay, so Dr. Abhijit, can we start now?
Yeah, we can start now.
Okay, so please uh, can you please share your screen?
Yeah, sure. Thanks, Aruna, for introducing me.
Thank you very much.
Can you see my screen, everyone?
Yes, your screen is visible.
Okay. Okay. So today I will going to discuss some basic.
Yes, sir. One thing, there is only the desktop is visible, but your slide is not visible.
Okay.
I think, can you please join with yes, yes, now it's visible. Yeah, now it's visible. And it is, okay, is it, can you please make it a full screen mode?
Yeah, it is full screen.
It's full
Uh,
screen. Okay. Okay, okay. Okay, no issue. Scan.
okay. So today I'll be going to discuss some basic introduction of ANN, what is its structures, and how ANN actually works, and what is the significance of ANN. And I will try to put some light on the error analysis of the ANN and its statistical significance, and why we should use the error analysis and why should we use the statistical analysis. The basic, I will just discuss the basic things why it is required to do, because I know that in machine learning and in ANN it's a vast topic. So I just try to in a hour try to make it a simple way to present before you, that you can understand the basic things and you can have and the interest grow in yourself, that you can then start learning the thing in a better way. Because I will not go into the more details, I will just try to make it more simple and try to grow your interest in this topic. So, okay. So what is the learning objectives of today's module? So we will be learning the basic structure of neural network. The first that you can that is the main motivation of our talk. The second thing is that we will learn the error analysis of the neural network, and then we will discuss why we do the error analysis using the statistical significances. Okay. So let's discuss why we need to learn ANN. The first thing is that ANN can have a huge amount of problem solving capacities. The thing is that you can use some voice recognition, you can use some like handwriting detection, you can make some auto driving of vehicles using that neural network, which is not possible by your regression process or something you have learned before. The second thing is that neural network is basically motivated by the human intelligence, like using you like it has motivated by our brain. So when we learn the neural network in a better way, it actually helps us to understand understand the human brain functions, and this can achieve some advancement in the neuroscience also. So we actually have in different two different achievements from the ANN. ANN can solve daily life problems, and an ANN can solve the neuroscience kind of things. Okay, so let's discuss why we should learn ANN. As we have already learned, I think in your BTech, or somebody who are in the BSc or in other fields in engineering or physics or mathematics, they have learned what is regression. So if I just have this data set, data set is for some dosage effectivity on some patients. This means that dosage has no effectivity. This means that the dosage has minimum effectivity, medium effectivity, and this has higher effectivity. So if I try to fit a line or a curve using the regression, using the linear regression, it can be like this way, that it can capture these two clusters, or can capture these two clusters, or can capture these two clusters. But it is not possible by the linear regression by any means to capture all these clusters. But if we have this neural network, it can fit a squiggle for these three data points, and then we can easily predict for, let's say, the dosage amount, and the dosage effectivity is this, and how much the dosage actually works on the patient. We can estimate from these. So basically, the thing is that uh, the linear regression, or the regression, or basically the regression, sometimes cannot capture the fluctuations in the data, or the intricacies of the data. So for that, we need some neural network to have that capacity to capture those kind of intricacies. Okay. So why we just need to know the linear and the ANN over the regression? Basically, ANN can work on complex and nonlinear problems, like that you have some voice recognition, you have some you want to know, you want to do some handwriting detection, or you want some autopilot kind of things, or you want to uh, like uh, uh, like uncover the mysteries of time series of many very kind of critical and very complex time series. For those cases, it is very important. The second thing is that it actually learns. It is called feature learning. So ANN actually can learn the feature of the data. I mean, if I say you cannot use the regression for detection of voice because the feature is not there, but in ANN, it actually has the ability to learn the feature of the type of the data. So feature learning is very important kind of an aspect of ANN. It has this capacity. ANN has the flexibility. It can work on categorical data. It can work on binary data. It can work on anything. And what is scalability? The scalability is that ANN can work on huge kind of data set. I mean, in linear regression, it is very tough to work on big data. But in ANN and in neural network, you can easily work on a huge data set, a big data set. The fifth point is that ANN actually is more robust for data which is noisy, uh, and also you can see that in some cases when you just collect the data, there are some missing data, and for that those cases, I mean, if you use a regression, the fitting may not be too good, but if you just use the ANN can learn that the data is missing, and then it can have some. Then it can use its own intuition and intelligence, and make and give you some good results. And finally, the performance is state of the art, because you know that nowadays, like, ANN is used in in many places. For example, if you just go to any coffee shop, there are many things, many places in USA. There is no people there, and you just tell the machine, vendor machine, and vendor machine actually gives you all the things. So voice recognition is a very important thing. Like that, I am a non-native speaker of English. My English is different than the American English, but it actually understand my voice. So the performance of this ANN is very good because it can understand what I am saying. So because it can learn from the uh, features of the data. That is the main thing of ANN. Okay. So, what is the overview of our today's talk? We will be learning what is the biological relation between the ANN and and the neural network, and what is the connection between our neurons and the ANN. Then we will discuss different types of artificial neural network and their structures. Then we will be discussing the learning techniques of the ANN, and then we will discuss some error analysis techniques and the statistical significances. Okay. So it's a cartoon picture of our neuron. You can easily see that this is a neuron, and it is the synaptic nerves, synaptics, and this is the cell body. This is the axon. So what happens here is that these synaptic nerves are connected almost like 10,000 kind of other neurons, and when the data actually transmitted into that neuron, so that data are actually have some these data actually stored in this neuron body, and they are uh, have some and they undergone some changes in that neuron, and then this data actually passes through the next neurons through this axon. And the thing is that uh, in case of our human brain, the data is transmitted at that time when the neuron capacity is overloaded. I mean, the neuron is taking information from many other neurons. It actually captures the data. It changes the data a little bit in its own way. And when it actually overloaded, it actually passes all this data into the next neurons. So So it is the bullet points of our brain, how it works. It says that a neuron is connected to other neurons through 10,000 synapses. So a neuron receives input from other neurons. Inputs are combined. Then when the input exceeds the critical level, the neuron discharges some spikes. So the spikes are actually discharges from the axon end or from the synaptic ends, and then this transmission is actually our transmissions are done by the neurotransmitters. It's a kind of chemical, and these links are called synapses. So now you see that, so neuron is kind of a hub, and it has many connections. The information is coming into that hub. It is and the information is changed a little bit in a different way. The using the neurotransmitters, using the chemicals inside the neuron, and then it is transmitted. So we'll be just trying to exactly simulate this kind of thing in our ANN, artificial neural network. Okay. So what is artificial neural network? So similarly, like our brain, And the building blocks of neural network are neurons. We actually call it units or nodes. So basically, each neuron receives one input from other neurons. It changes in its internal state the information, and then it sends out these signals to the other neurons. Okay. So you can just see the cartoon picture here. I have make one brain part here and one neural network part here. So it is similar. It is just same as the neurons working like a neural network. So information is coming. Like uh, uh, information is getting some new way of getting some transformation, and then it is transmitted. Okay. So it is the main important picture of diagram of ANN. So like the neurons, dendrites are connected through many other neurons. Information is coming. So same is here. This information x0, x1, xn are all inputs coming into the neural network. These are some weights. Weights means like if you say that the information is coming into this neuron, this neuron actually have some capacity to hold the information, and actually the neuron actually do not hold the information in that. Like for example, if you read some poem and if you memorize that, the thing that stores in the brain is a kind of chemical, not that words. So the thing is that when you just give some inputs, the inputs are actually transmitted in a different form. That is the weight. So weight is the exact semblance of the thing that happens in our brain. That information comes, it stores in a and information stores in a chemical way, not in that words or like this. So these are the weights of the uh, different nodes, and then these nodes and then these weights and these inputs are multiplied, and they are summation, and then it is passed to the next neuron. Now what is this part? This is called activation function. I will come to that point later, but I will not discuss it right now. But the thing is that, so in artificial neural network, the main building blocks are: first you have input. The inputs come into the neural network through some weights. Then the in weights and the inputs are multiplied. They are summationed, and the summation term is going through some activation function, and then they are sent to the output. So it is the exact semblance or imitation of the human neuron. Okay. So it is a more clear picture. This is the inputs, this is the weights of all the edges, and these are summationed, and then it is the output. I have just discarded the activation function here because I just want to make it more simple for the outset. Then I will discuss later what is the meaning of activation function. So, it is actually, we actually call this a black box because we do not know that what exactly happens within the black box, because the things are actually changed when you just train the neural network. The weights are changed accordingly to get a better performance. So we do not know exactly how the weights are changing. So that is why we actually call it black box, and it is actually a drawback that we cannot in a I mean, we cannot exactly find what actually happens within a neural network, because the weights are actually changes accordingly the neural network wants. Actually, it has own intuition. It actually trains itself in a better way always. So it is very difficult to predict what is going on inside. So it is called a black box. Okay. Okay, now let's discuss what is the need of activation function. So let me just draw a picture here. Let's just see that what I have discussed here. Uh, what I have discussed here, like in this part, in this part, is my screen visible? Board visible?
Yes, board visible.
Okay. So if you just add these all terms like this,
Now it's not visible.
okay, it is outside the.
It's yes, yes, outside exactly. Yeah, yeah.
Okay.
Yeah, now it's visible.
So if I just add these all terms, just see that it's a kind of linear term. So for example, if I want to fit a data like this, let's say it is the dose, it is the effectivity, and I have medium effectivity, zero effectivity, and the high dose having no effectivity. And if I fit a regression line, it looks like this because it's a kind of regression. It has no nonlinearity. So if I want to make this curve to be bent or squiggle, I need some other functions. So, for example, if I say I put some function over this quantity, summation I equals to 1 to n, wi xn, sorry, wi xi.
Hello.
Hello?
Yes, it's now again the board is actually not visible. Yes, just a little bit right side, I think. No, no, opposite side.
This side. Is it visible?
Yes, yes. It's now it's visible. Yes, yes, yes. Now it's visible.
Okay. So this function actually requires to make this straight line to be a squiggle because we cannot make this linear thing to be fitted for like data having many fluctuations. That is the requirement of activation function. Activation function is those kind of function which helps us to make the linearity into non-linearity. Okay. So let's discuss what is the activation functions requirement. Like activation functions are mathematical functions applied to the weighted sum. We applied over the weighted sum, and they determine the output signal that neuron transmit because we actually takes the output after applying the activation function. So it is obviously the output is an composition of the activation function. So activation function introduce nonlinearity in the network. It is obvious because we actually want this function to be nonlinear so that the data can be well fitted. And obviously, without activation function, it is not possible to fit a data because without activation function, neural network is kind of a linear regression kind of thing. So without activation function, there is no meaning to use the neural network. Okay. So there are different kinds of activation functions that can be used and that can be modified according to your need, but mostly we use these six different kinds of activation functions in our daily life problems or things. The first one is linear activation function. It is a straight line. The second one is it is called step activation function. It means it is a kind of a step function like less than 0 it is 0 and less greater than 0 it is 1. It is a sigmoid activation function. It looks like a kind of a S shape. It looks like a shape like this. And this is called hyperbolic activation function. And this activation function has range 0 to 1. And this tan H has range
Excuse
minus.
me. Hello. Yes.
Hello.
One request. If you can please write on the board from some your left side of the board where the black. Yes. Already it
Okay.
is written temperature or something. Yes. More.
Well, that's this side. Okay.
Yes, that
So,
side where it is written temperature. Yeah, yeah, yeah.
so what is the tan hyperbolic function structure? It looks like, for example, it looks like this. So the range of the tan H function is -1 to 1. The range of the sigmoid is 0 to 1. And simply, if you just see it is called ReLU, rectified linear unit activation function. This says that fx is max 0x. So simply, if you just draw the graph of this ReLU function, it looks like this, that whenever x is negative, it is 0. When it is positive, it gets a bent. So it's a kind of function like this. And the second part is leaky ReLU activation function. It says that whenever x is positive, it is x, and whenever x is negative, it is alpha x. So it is not exactly 0. It is kind of like some alpha x. If alpha is positive and it is negative, then it will be like, sorry, it is like this. For alpha positive, it is like this, and for alpha negative, it is like this. So mostly, to make the data nonlinear, we require these sigmoid and hyperbolic activation functions, and to make the data to be linear, in some cases we require this ReLU or leaky ReLU, or sometimes the linear activation function. Okay. So what kind of data we can feed for the in the ANN? So ANN actually is flexible for any kinds of data. So we can feed binary data. That means the data has only two outcomes. Can be 0 1, can be yes no, can be true false, can be presence absence kind of things. And we can use categorical data. So what is categorical data? So uh, if I simply say that, for example, if you want to translate something in the Google, for example, if I say that if you want to translate that how are you in Hindi. So if you write this in the Google Translator, so it starts uh, translating using some one hot encoding way. So what is that? I mean, the computer cannot understand a word. It always understands some binary thing. So for example, if I say how can be how can be expressed as a binary data like this, like h is in the position 1. So I can write h as 0 0 0 0 0 0 0 1 A B C. Okay. So the thing is that there is no A B C D E F G, but H is present. So we can write H as A B C D E F G H. H is present and nothing is present here. A B C D E F G. So they are 0. Similarly, we can write O in this chain, making other things 0, and W making other things 0. So in that alphabet, only take H, O, and W values to be 1, and rest alphabets to be 0. This is called one hot encoding. So now if I just put these things into the Google Translator, it understands that that I have given how. Then it will change this thing into a Hindi or something what you want. So categorical data is very important for the ANN, because most of the things are categorical data. Because if you just give any, let's say if you just for example, I can give you one more interesting example. Like if you just want to play a TikTok toe game with the machine, and let's say you just put one X here, the machine will try to put some O, but it doesn't understand what is X, what is O. It understands these things kind of a matrix or kind of a binary thing. So how can you just understand this thing? Just see that uh, I just erase this part because I do not know how much part is visible to you. So you can take a pixel, 6 by 6 pixel, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. So what is X? So just see that. So X has a structure like this. So I can say that X look like this. That I just make these boxes to be filled with black pen. And it is X. And how the O is calculated? So O can be like this. 1, 2, 3, 1. So we can start from here. This like this. A sort of like this. So it's a O, it's a X. So it understand in this way. So whenever you have a black here, it is 1 and these parts are 0. So it understands that it's a 6 by 6 pixel. Whenever you have written some X, it understands that in those 36 pixels, the position where it is 1, where it is 0, and it then have the knowledge that I should not write X there, I should put a 0 there, otherwise I will lose. So the categorical data is very important because everything like speech recognition, the handwriting, like if you train a car, everything is categorical data. Or if you just want to change the language, so everything is categorical data. So it's a very basic way to handle the data. It is called one-hot encoding. That you just change the data to some binary stuff. Okay. So what is bias? Uh, so I can give one example here because bias is a very important stuff in machine learning. Without bias, you cannot even get a good fit. For example, if I say that if I say that I have some data points like this, and I want to fit a line to this point. Let's say I start from the line y equals to x. Okay, let's say the point is here. So it is the line having no intercept. It is the line passing through origin. Now you can see that this is not a good fit. But if I add some, for example, if I want to plot some x plus 2, then it can be like this. So it is a better fit than the previous one. So if I add this 2 with this output, we can have a better fit. That is called the bias. Bias means that you have like after the activation function is applied, like just remember the process. You have the input, then it is, and there is a hidden layer in the neural network. Then there is a activation function, and then we discuss there is the output. But there is a caveat. The caveat is that between this step there is a bias is added with the activation function. Like we should not always get a good fit after applying the activation function. Maybe we get a squiggle. For example, if I say that let's say I have data like this, and I got a curve like this, but it is not a good fit. But if I, for example, add with this thing, this quantity, let's say 3 plus 3, then I can get a good fit like this. So it's a bias. So plus 3 is the bias. So after applying the activation function, we need some bias. So bias is in between these two steps. So bias can be negative, bias can be positive because we sometimes need to uplift that, or we sometimes need to downsize that. So bias can be of both sides. Right. So what are the main different types of neural network? ANN. So ANN can be feed forward, it can be feedback, it can be recurrent neural network. So recurrent is kind of a feedback, but not exactly the feedback that actually works. It has some more complex structure. So now we discuss the type of connectivities. So what is a feed-forward network? Feed-forward network means that there is nothing loop happening within the network. You just have a input. There is some hidden layers, and there is some output, and the information actually flows directly in this direction. First, you just got some inputs. The inputs undergone some changes, transformation inside the hidden layers using by the weights, and then they are passed to the outputs. But in the recurrent neural network, the thing is that when you just pass through the information through the neural network, they does not just simply comes out of the network. After going to the output level, they actually feed back again in the hidden layer, just to understand whether the feeding is good, or the performance is good, or the training or testings are can be make more better. So these things are actually happens in neural network in the recurrent neural network. Basically, the thing is that recurrent neural network is applied on sequential data. So always you cannot, for example, if I say that, uh, let's say, uh, what is the trend of the stock price of some company. So if you apply the simple feed forward network, you will uh, get some unrealistic fitting, because it does not understand the underlying feature of the data. But if you apply the recurrent neural network, it will try to learn what happens in the past, and then it will give some better output. So recurrent neural network is very important, where the data is very much dependent on its states, right? And there is more sophisticated one than the recurrent neural network. It is also a class of recurrent neural network that is called LSTM, because recurrent neural network cannot remember the old history. But you know that in stock market you need to understand the portfolio, and you understand the old ups and downs in the market. Then you can have some understanding of the future. So in case of recurrent neural network, it cannot remember the old data features. So therefore, that case we require to use some other more sophisticated one that is called LSTM. And obviously, LSTM is not applied in stock market. It is applied in also in many time series things, not only in this thing. Because like if you just see the climate forecasting, so how it is done in the meteorological cases, LSTM is broadly applied, because nowadays you can see that the meteorological forecastings are more better than what we just heard in our childhood. So these things are actually improved because we are using the better neural networks that has better understanding of the features of the data. Okay. So there are different kinds of feed-forward neural network. The basic one is having only an input layer and an output layer. There is no hidden layer. This is a very basic one. It can be multi-layer, like it has input layer and one hidden layer and one and output layer. Or it can have multiple hidden layers. Like here we have taken two hidden layers and one output layers and one input layers. So there is no looping inside the network. The information is just flowing from from starting to the end. Okay. So simply you can just see that what I have just discussed previous in the slides, that you have some weights for all these inputs. These are multiplied. These are summation, and then this is went through some activation function, and this is the output. Okay. So what is the feedback network? So just see that you have the inputs like here. The inputs are passed into the outputs, but these are not actually the output. They are again feeding back this data again to the again in the input level. And so we can see that there is a kind of a time lag here, after t seconds, or let's say t unit of time, you got the output, but the output is again fed back to the input, and then we got the output. Because it is important, as you know, that feedback is always very important in our body. For example, it is in the for example uh, like when we actually sweats, it happens that body actually stops sweating. Then it then the sensory organs, the epithelial cells in our skin gives the sensation to our brain that our body is not fully cooled down. Then it again sweats. So it's a kind of feedback. So something happens, then the information is again fed back to the original system input, and the system again starts working. So feedback is important because not everything is linear. Some things sometimes in some process, in some process, the things should be repeated to get some better output. So feedback is very important in our daily life problems. Next, we discuss what is the recurrent neural network. So recurrent neural network is those kind of networks where after the information is passed to the output level, the information is again fed back to the output level, and there is some detection system which can understand that how much errors happens, uh, how much training set can be modified, or how much the learning can be modified, so that the output should be more closer to the actual data, and and therefore we can have some better forecasting of the system. That is the neural network. That is the recurrent neural network is very important because the recurrent neural network actually works in two different ways. It works as a feed forward, it works as a feedback, and it has some looping, and it has some internal checking whether the output is good or not, and then it actually modifies its outputs by changing the weights and the layers. And you can just understand that in the recurrent neural network, the hidden layers structures are actually changed if you just train the model again and again. That is the very important thing. So recurrent neural network is very important because it has the feature of uh, modifying itself through changing the weights, changing the layers to get a better outcome. Okay. So obviously, it is very important to learn our neural network through the data. There are two different kinds of learning. One is parameter learning. Parameter learning means that you just try to learn, you just want to learn your network that what is the good weights for the edges. And what is the structural learning? Structural learning means that sometimes you may require some multiple hidden layers, more neurons, or sometimes you require some simple neural network. Because sometimes if you just go with more uh, like complex neural network, in that case you may get some overfitting. You may get some overfitting. I actually have this experience in my work. So it is very important that you should learn your model in that way, in a optimum way, that it learns what is the exact or what is the optimum values of the weights, and how many layers, how many neurons you should require to use to get a better output or better outcome. Okay. So learning in the ANN can be done in different ways, but I will just restrict my discussion in two different, that is called gradient descent, and second one is called back propagation, the two algorithms. So basically, the thing is that you simply calculate the output. YI is the output that you have, like YI is the real world data, and if WIXI is the output you got from the uh, uh, neural network, and you take their differences and you just take a square. It is called the sum of squared errors, SRR. So you just try to minimize this error using these two techniques. One is gradient descent, one is backpropagation algorithm. So basically, these are the two sides of a coin. Gradient descent actually applies in the backpropagation, but I will just discuss in two different slides. So what is gradient descent? What is the meaning of gradient? So simply, if I just differentiate a function having one variable, that is called derivative. But if I have a function having more than two variable, and if I differentiate it, it is called gradient. I mean, a function having more than one variable, if I differentiate that function, that is called gradient. So, if I uh, have a curve like this, and I want to find the minimum point of this curve, that where the function is minimum, then obviously as it has more than one variable, those who have learned in the BTech first year the several variable, I think they have learned this thing, or those who haven't done, I will just try to explain this thing. So if I have a function like this having two variables, we need to differentiate for the two different variables. And then we need to do some mathematics to find the minimum point. The thing is that we need to differentiate these things partially because this is not a single variable. Now, the gradient descent thing is that when your starting point is far from the optimum value, the gradient descent actually goes very fast. But when you are very close to the optimum value, it actually goes very slowly. So that is a very good thing because you will not just miss that point, because if you are far, it will come closely to the point, and if you are very close, it will just slowly approach that point. That is the good thing of this gradient descent. Now the same thing is that you can see that the jump is higher here, but the jump is very slow here. It is slowly approaching this point. So in every step, there is a kind of change happens with the optimum value. That is called the learning rate. So I mean, the learning rate is kind of fixed in neural network, but you can change that learning rate. So I have given an example here that del W is the change you make after every step. Like for example, you get a point, let's say after some calculation, you get some point. Let's say this point has value 1 comma 2, and delta W is, let's say, 0 0.5, 0 0.7. Let's say uh, let's say minus 0.5, minus 0.7. And if I add these things, or if I multiply this with this, it is a kind of a dot product. So it will be just multiplying the coordinates and coordinates. It will be minus 0.5, minus 0.14. I'm just giving an example. So what I have done this. This is our delta WL. This is our learning. Sorry, this is our learning rate. If I multiply these two things, we get the new starting point. The learning rate is very important for the case of gradient descent. You can change that, but mostly in the neural network, this is fixed. And this is very small actually. Okay, so I just try to make it more clear how we just explain what is the gradient descent. Okay, so I will just try to make it. I actually have to discuss more things. I don't have much time left. I'll try to make it concise. Okay, so just see that in the left hand side, I have two data points here, and I have taken the line y equal to x, and I have taken the sum of square residuals, that this data point has value 1.4. It has, let's say it is 3.2, it is 1.9, it is 1.9, it is 1.4, and I have taken the line as y equals to mx plus c. So ms plus c means m is the slope, c is the intercept. So intercept plus slope into x. So you see that I have taken the sum of square residuals, and I want to find the optimum intercept for which the residuals is minimum. So here I have taken one graph for the residuals and the intercept. You see that what this graph tells you. So whenever you have the intercept to be zero, at that case you have a very worst fitting. That means the sum of residuals is very high. So in that axis, it is your SSR, it is your intercept. So it is very high. But if you make the line like more closer to the data set, and if you just take a higher intercept, let's say 2 or let's say 1, then you have a better you have a lower SSR. And if you just do these things little bit more, and then you just finally reach your optimum value. So you can just see that at this point you got the minimum, and again if you just move upward, you have a better you have a worse fitting. So simply, if I say that try to find this optimum value, you can do in this way. You can just go slow by you can just go every step. Let's say 0.01 increment, and you can check the uh, values, and you can compare the values, and you can find the minimum value. But that is a very painful process. So we require some method to find that minimum value. That is, and in that case, we actually use the gradient descent. Just see that. Okay. So if I just differentiate this function, which is the function of intercept, with respect to intercept, and then make it zero, as you know that you can differentiate a function, then you can make it zero, then you can take the double derivative like this. You can find the minimum value. That is the way you can use the calculus, the gradient descent, to find the minimum, instead of going through this painful process of going slowly one by one and checking the values and finding the minimum. Okay. So what is back propagation? So it is exactly the other side of the uh, uh, gradient descent. So simply I will give the example like here. Let's say I have a neural network having one input, and this has two hidden layers. I mean two hidden neurons, one hidden layer, two hidden neurons, two nodes, and one output. And if you pass this dosage values from this side, this gives you a curve like this. And if you pass through the dosage values through this one, this gives you a value like this saffron one, and this blue one is for the upper layer, and this saffron one is if you pass to the lower layer. And if you add these two values, you will eventually get a curve like this, but it is nowhere closer to this value, right? So after applying how you got this? You got these two curves after applying the activation function that I discussed before. But activation function is not enough to make this data set more closer to the values of this dosage. So we need some more modification that is done by the bias. So it is called the bias. So back propagation actually tries to find that exact bias that is required, so that this data set will be closer to this points. So how you can find this? Let's say you have these values here, and then you just find the differences of this point and this point, this point and this point, and this point and this point in terms of bias. Then you differentiate it using the gradient descent, and then you find that exact values of the bias for which the difference is minimum. That is called the gradient descent used in back propagation. So back propagation actually helps you to find the bias, or sometimes you can also find the weights also. I mean, here I have given some arbitrary weights to fit the data, but you can also find these weights using the gradient descent. It is also back propagation. You just make a function of the weights with the output, make a SSR, the square sum of residuals, and then you differentiate over all these biases and the weights, and one by one find their optimum values. Okay. So I've given the example here that you have added this bias 2.61 using this back propagation. I have defined this SSR here, and after a certain level, I got the bias to be 2.61. The 2.61 value is this value, and if you add this value, you can get a very good fitting. So back propagation actually uses the gradient descent. It is nothing else. You just try to find the values that is required, uh, that is required to get a good fitting. The bias, the back propagation can be applied on the bias, on the weights, or you can only apply on the weights, not on the bias, if you know the bias previously. So it can be applied on these two things as per your choice. Okay. So what is the training? So training is the process of modifying the weights in the network layers. Like you have some output, you have some input, you want to capture that output, you need to change the weights, and you need to train the network so that the weights should be optimum. That is called training. Okay. So training can be done in three different ways. The first one is supervised learning training. The second one is unsupervised learning training. The third one is reinforcement learning training. So what is supervised learning training? So if I say intuitively, for example, if you are in class 12 and you are doing some calculus, and you do not know how to integrate, so your teacher actually gives you some examples that you should do these substitutions, you should do these substitutions, and then you learn from those examples that I have to do this kind of things if this situation appears, or these things if this situation appears, and then you can apply your knowledge in a different situation. That is called supervised learning. So you have some inputs into yourself by some training, and then you gather those information, you just try to then correlate that information with the new scenario. So that is called supervised learning. And we actually call this data, when a teacher actually teaches you something, we actually call this a labeled data. Labeled means the data has some meaning. It is not a casual thing, it has some meaning. So it says that supervised learning is a type of machine learning where model is trained using a labeled data, and the label data is consist of input data and correspond desired output. Obviously, the model learns relationship between the input and output data, allowing to make it predictions for the new and unseen data, because you have some training and you just work in a different problem. Sorry. Okay. So what is unsupervised learning? For example, let's say if you just try to understand what is the basics of machine learning and artificial intelligence by your own, that is a kind of unsupervised learning, that you do not have the basic training and you just trying to figure out what is the machine learning, and then you just try to figure out what prerequisites you need to learn. For example, you need to learn some statistics, you need to learn some linear algebra, you need to learn some mathematics. So you just figure out that I have to learn all these things to learn this machine learning. So it is called unsupervised learning. So unsupervised learning means that you are not given with some label data. You have given some information, and you are trying to figure out that, okay, this part relates to mathematics, this part from the statistics background, this part from the linear algebra, and then you just separate those information, and then you just learn the thing. That is the main idea of unsupervised learning. That you just make some clustering there. You just try to understand that when you start reading some new book, new mathematical idea or new physical idea or new statistical idea, you just try to figure out what you learned previously, and you just try to cluster out these things separate, so that you can have that knowledge that this part is coming from the statistics, this is from the biology, this is from the mathematics, this is from physics, kind of this. So obviously, as the unsupervised learning has to do with clustering, so we actually use we actually use the unsupervised learning in case of clustering the data set. I'm giving an example here. Okay. So, what is the task done by the unsupervised learning? For example, if you just take a data in the Walmart, that for example there are some age group of people shops in the Walmart, and you just try to figure out that for example cheese, that which age group buys more kind of cheese, and then you try to figure out that let's say the ages from 12 to 16 buy some cheddar cheese, the 16 to 20 buys more, has more affinity to the mozzarella cheese, or I do not know all the kind of cheeses. So you can cluster the cheeses by the age groups. Or you can say sometimes you have data which have very high dimension, which is not easy to visualize. You can embed all this data in a lower dimension. So embedding higher dimension data in a lower dimension means you are just uh, lowering the spaces. I mean, it can take huge space. You are just lowering the space, but the visualization is same without changing the basic properties of the data. So you can have this clustering kind of things to be done using the unsupervised learning. Okay. So what is reinforcement learning? So reinforcement learning, I give some example. For example, if I say a mouse is a mouse get lost in a maze, and is trying to find the right path to get out of this maze. And the thing is that the maze is structured in this way that if the mouse, if the mouse, if the let's say rat, if the rat takes the right path, there should be a cheese, and if takes the wrong path, there is no cheese. So the rat will be very much eluded for the cheese, and it will always try to find the cheese so that it can find the right path. So it is kind of a rewarding technique, that you are getting some reward if you do the right thing, and you are not getting the reward if you're not doing the right thing. So reinforcement learning is a machine learning where the agent interacts with the environment and learns to trial and error, and the agent receives rewards for desired action and penalties for the undesired action. I mean, if you just, for example, if you just play the game that we used to play in our childhood, that play of the game of the snake, that eating some balls and getting bigger and bigger, and if hits the side wall, it will die. So there is a kind of incentive that hit the ball, it will get bigger, and if you hit the side walls, you will die. So from there, you just learn that I should not hit the boundary walls. I should just move around these things, and then I can get some rewards by some food, and I will get bigger. The reinforcement learning is the most important things that is applied nowadays in case of uh, artificial, like the autopilot things. For example, if you just look at the Tesla autopilot car, uh, like how it actually learns. So it does not learn in a single day all the things. It actually learns day by day that you should how you should brake, how you should push a brake, how you should accelerate, or how many times the signals becomes red or green. So all these things are actually inputted in the model, so that you can have a better autopilot car. Or for example, if you are going in a three lane, So which lane you should choose? Because in USA, people actually choose the left lane for the bigger car and right for the smaller cars. Exactly the opposite in India. So for these cases, how your car will understand that I should choose the smaller, I should choose the righter one, because the left one is for the bigger car. So it should have some understanding of the size of the things, the the amount of acceleration it should give when there is a lot of like clogging in the road, or how many times it should wait when the signal is green or signal is red. It should not it should wait. I mean, in USA it is always a customary to wait when people crosses the road. So all these things are learned by some practical experiences. So it is called the reinforcement learning, that try you just learn from trial and error from the environment, and then you have a better system to operate. Okay. So what is error analysis? It is very important because you always try to figure out that how much you have done better in every performances. And it is done by checking the differences between the output and the and the actual data. So why the error actually happens? I mean, what kind of errors actually happens in the neural network? Sometimes you get overfitting, sometimes you get underfitting, sometimes you get vanishing gradient. For example, if I say for this curve, the gradient is zero here, or if I go here, the gradient is, I mean, exploding. It is actually 90 degree. So in those cases, it is very hard to. I mean, in those cases, you need to calculate the error, because in this case, you should not apply this gradient. You should not apply this. I mean, here you cannot apply the uh, derivative, because derivative is not. It is infinite here. And obviously, the data actually has some noises, inherent noises, which makes the data inconsistent, or there is some fluctuations, random fluctuations. For these cases, the error actually happens because even though the neural network is able to capture all these fluctuations, but I have seen in the geospatial cases, because people actually works in a lab, I have seen their works is not very. The network is not very well trained, so that it captures that all those geospatial fluctuations. So noise is also an important thing which actually yields some errors in the neural network. So what are the different kinds of error functions? We can find the mean square error, that is 1 by n. It is y hat is the output, predicted output, and yi is the actual value of the data set. You can find this kind of sum of square errors, mean square errors, or you can find the cross entropy. It is in the log scale, because these values are actually very high. Whenever you try to put these things in the logarithm scale, this is very lower values, so it is very easy to calculate. And it is obviously, and it is actually called the likelihood function in some other way. So this has some connection with the statistics or Bayesian analysis. So you can done in these two ways, or you can done in the way that you just take a modulus, or the absolute value of the differences of yi and yi hat, and you can also take the RMSE, the root mean square error of this error. Okay. So how we can mitigate the errors? One way is that we can use some dropout. We can drop out some layers, because as I told you that sometimes a simpler model can perform better. So we need to drop out the layers. Sometimes, I mean, it is very important in case of neural network that data is very important. You cannot work on a very low amount of data set. It is very hard to capture the fluctuations. I mean, it is always required for the neural network to train for a good number of data. So if you already have a very lower amount lower number of data in your hand, you cannot train the model, because the model actually requires some training, some testing, then you can just take the output. So so the data is very important, the number of data points. That is why sometimes you may require to add some more data in your model to get the better prediction, because the neural network always needs some good data, good amount of data. It need to feed with good data. It is very important. I mean, it is actually a drawback of the neural network. And sometimes, if you have the idea of the neural network, if you have once tried these things, sometimes we actually give the epoch value to be 1000, 2000, or like 4000, and we see that if we just go higher values, this gives you some overfitting. So sometimes stopping at the initial level can give you some good fitting. I mean, it can mitigate the errors. Okay. So when we just do the error analysis, we need to understand the statistical significances. Like the like uh, when you just change the errors, when you just modify the errors, it means you are changing the layers, you are changing the biases, you are changing the weights. So sorry. So you so you are changing the weights, changing the biases. So obviously you need to check whether the change is good or not. So for example, if I say that I have changed the error values biases to that value, and it was initially that, and in these two cases the outputs are this, and we can check their and we can test whether these changes are good or not by some statistical test. That is the importance of statistics here. And obviously, by applying statistics, you can have the idea that if I change these values of the weights to that, this is good, and then you can have some prediction over the weights, that changing the weights or biases to that is good, and you can have some conclusion over the data set. So basically, it is very obvious that when you compare two results, you need to check the hypothesis testing. So for that, you need to define two hypotheses. One is null, and one is alternative hypothesis. So the thing is that, for example, if I say that I have two events A and B, and I want to check whether there is any significant difference between those two things. I can define that I can define in A0 that there is no significant difference between the performance of model A and model B. And I can define that there is significant difference between the performances of model A and model B. And then we can run some statistical test. Like there, there are many tests which are applied over this hypothesis, but mostly we use t-test, which is applied for comparing two different groups. And obviously, the t-test requires the sample values to be at least 30, sorry, less than 30, because, sorry, no, it should be at least 30, yes. In the case of ANOVA, it gives you a more,
Hello, I think it's less than 30 t-test.
oh, S test is greater than 30, right?
Z
Z
is
test is
greater
greater
than
than
30.
30. Sorry. Yeah, Z test is greater than 30, T test is less than 30. In ANOVA, you can compare more than two groups, and in the chi-square test, you can have you can compare the categorical variables. So that is not actually calculated through the ANOVA or the T test, but you can do it in the chi-square test. Okay. So after doing that testing using the statistical test, you need to define some significance level, that whether the test is reliable or not. So that is called alpha value. So simply we define that alpha to be 0.05. For example, if I draw a diagram here, that you are saying that your data to be normal, and you are defined that alpha to be 0.05. That means there is some confidence interval that between this you are sure that this is this is to be a normal distribution. But outside this part, it is not normal. So it can be two-sided, it can be one-sided, because t-test can be both-sided. I have taken the two-sided one. So so if I say that alpha is 0.05, so inside that part, you have uh, this distribution to be normal. And outside this, that is 0.05% probability that it is not normal. And what is the p-value? So in case of statistical learning, using the different test, the p-values is very important, because p-values actually gives a probability that whether the observed difference in the performance of output and input uh, are actually valid. I mean, p-values actually calculate whether your uh, two hypotheses are actually valid or not. I mean, if the p-value is greater than this uh, significance level, that means you just reject the null hypothesis. And if your p-value is greater than this, lesser than this alpha, you can accept this uh, H0. So p-value is actually very important to define. I mean, we actually take p-values to be 0.001 or sometimes 0.0001 to be very low, so that we do not overestimate, we do not actually over accept the basic hypothesis. But sometimes you can have some higher values of PSP. Okay. So the final slide is that what are the drawbacks of neural network? So uh, neural network actually requires some huge amount of data. That is a very obstacle or very bad thing of the neural network, because you need to do some training, testing, and learning all these processes. The second thing is that neural network actually gives you some output, but you do not know what is going inside, because you do not know what is the models. Uh, can you please mute for a minute, because I'm just finishing. In the neural network inside part, there is a black box. You do not know what is actually going inside the black box, so you do not know actually what is the model that the network is working on. But in case of linear regression or regression, you have the exact model. So neural network does not gives you the exact model. You can find in some way. You can find it some way. There is way, but it is not very easy to interpret when there is huge number of uh, when there is huge number of like layers, hidden layers. Okay. That is the basics of neural network, and after that, you can just start like uh, there are many blogs in the Google. You can start reading those blogs, and I will suggest that you can start using R, because R is more flexible. When you just try to write the codes in R, you can easily write it, because in Python or in MATLAB, you need to learn some more structural things. But in R, you actually have a easier way to write the things, because it's a higher level language. You can easily write many things without writing those basic things. So you can start using R, and you can start reading some blogs, and you can start exploring. That is from my part.
Okay, I think uh, yes, is it finished, right?
Yeah, it's finished.
Yes, okay. Okay, thank you very much, Dr. Abhijit. That's okay. I want to ask the students, is there anybody has any question? Please write down in the chat box, students. Any question you can write down in the chat box, or you can unmute yourself and you can ask.
I think
Okay,
they do
no
not have any
question from.
questions.
Yeah, I
We can.
think so. I do not have any question. Okay, so there are some of the questions from the outer audience. So the question is the regarding one question is regarding the activation function. Okay, so if the suppose it is the data is not categorical in some cases, let us suppose that any continuous output, let us suppose we are going to predict some other means the marks of the students, okay, or the height or the weight of the of any kind of students or any entities, okay, based on some previous input data set. And basically uh, except the categorical data. Categorical data is only either the binary, that is yes, no, or more three or more categories are there, but the data is continuous. So in that case, which kind of activation function is more suitable or most suitable?
So in case of continuous data, obviously the data should have some fluctuations. So we need to apply the sigmoid or hyperbolic activation functions, or maybe we can come up with our own activation functions because we need to capture those fluctuations.
Okay. Let us suppose if the data set is it following more like a normal distribution, can we use the Gaussian curve?
We can use that function. We can use that Gaussian function, like e to the power minus x squared by 2, like this.
Yeah, yeah, exactly. Okay.
Because the data because the activation function's role is that it actually transforms the values into the shape of the data.
Shape of
So
the
if
data.
because if you just know what is the shape, what function can make the shape, you can put that function. I mean, you can put the values inside the function, and you can have that shape.
Yeah, 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 exactly. So it means that the activation function, if we means want to predict the activation function, means which type of activation function is suitable for that. Okay.
Mhm.
Is it better to plot the output data if it is not categorical?
Yeah, yeah. Because in case of category, not categorical data, you can start you can start fitting the data with some function. You can have the idea what
What?
functions
Yes, yes. The
which data
function we can.
you can use that function in
have.
the activation function. Mhm.
Okay, okay. Okay, so is there any other question from any students? Okay, well, okay. Yes, I think no students has any question. So I would like to thank Dr. Abhijit Majumdar, and the session is a very beautiful session, and just enriched us with a very good information, and it's the or each and every means insights are too much informative. And this all this session, whatever the knowledge we have gathered today, and it will be beneficial for all the students and all the interns in the InnovaWorld for the future projects. Okay, so again, I would like to thank and to Dr. Abhijit. Okay, so it's a pleasure
Thank you.
from that you came and you delivered such a beautiful lecture with us. And I hope that in future also he will be connecting with us and for some collaboration. Okay,
Yeah, sure.
so okay, so thank you very much. So
Thank you.
okay, thank
Yeah,
you
yeah,
very much, Ajis.
I can send the PDF or the PPTs to in the YouTube channel. You can find from there. Sure.
Okay, okay,
Okay.
okay,
See you guys.
okay. So Okay, so students, you can leave the meeting now.